Hi, linear algebra students. We are in the section 2.2, inverse of a matrix. And in class, I stated three important properties of invertible matrices, okay? I proved the first property in class, which was that the inverse of an inverse is the original matrix. So we proved that in class. And I'm going to make two videos, one with the proof of the second property, which is right here, and one with the proof of the third property, okay? So before I begin the proof of this, I just want to say why it's totally on your reach, okay? You can do this by yourself. And the reason is because these three proofs are essentially the same. What you're doing is you're taking the candidate that's over here. I will call this like a candidate, okay? And the idea of this proof is to verify that the candidate works in the definition of an inverse. Okay, if after this you're still clueless, okay, what I want to show you is what we want to prove actually is that we want to prove that AB multiplied by B minus 1, A minus 1 is equal to I, and that B minus 1, A minus 1 times AB is equal to I. So now my big suggestion is really to close the video here and try to prove these two things. If you are able, then you verify that this matrix is the inverse of this matrix. Okay, make sense? All right, so I'll do the proof of this here and the proof of this here because at this point it's actually quite easy. We're using the associativity of matrix multiplication. So I'll write this in red, let's say. So by associativity, okay, we know that AB multiplied by B minus 1, A minus 1 is equal to A times B, B minus 1, A minus 1. Okay, so we know that, and I'm going to split my board in two at this point. I'm going to go like this. We also know that this right here, B minus 1, A minus 1 multiplied by AB, is equal to B minus 1, A minus 1 times A times B. There we go. Okay? So here, as you can see, these are inverses of each other. Okay? So this is actually giving I. Okay? So this is enough to show that this member over here is actually equal to A minus 1. And then the same thing happens over here. A and A minus 1 are inverses. So this is equal to I. And as a result, this whole member is equal to I. Okay? And this part, as you can see, is checked. So we checked that this is valid. Now let's check that the other side is valid. Well, it's the same idea. Look, A minus 1 times A is equal to I, which means that this thing is equal to B minus 1 times B. And then realizing that B minus 1 is the inverse of B, this multiplication also gives I. So that's it. You're done. You succeeded to prove that b minus 1, a minus 1 is the inverse of a times b, which is really what this formula tells, right? So just to specify it, so this is inverse of AB. Like in English, that's what this notation means, okay? So we proved that b minus 1, a minus 1 is indeed the inverse of AB. All right, see you in the next video in which I'm proving the next property, so the one with the transpose. See you there.